Hey everyone, Keegan here from Curious Engineering doing another tutorial video on servos. So servos are a great component to be comfortable with. It's what will turn your code into physical motion in the real world. And the real motivation for this video is just to show some best practices so that you can really understand how they work, as well as so you don't get frustrated and move on to a different component. Now, if we look at some of the offerings online, Adafruit has just a standalone component that you can get for around 12 bucks. Seed Studio is another great company. They have a module where you can directly hook up with a 5-volt line, as well as some different kind of attachments for around 25 bucks. You could also go to Radio Shack. They have that, or my personal favorite, Fry's. Anyway, so just these components are out there, and feel free to play around with them and get used to them. So the next sections I'm going to go into are some schematics, so we can learn how to hook everything up, and then we're going to walk through some of the code and see how these things actually are working once we've done all that. Okay, as I mentioned, we're going to go through two examples. We're going to go through the sweep example and the knob example. So sweep examples are just going to go from 0 to 180 degrees, and it's going to do that back and forth. And the knob example, we're going to utilize a potentiometer pin or a potentiometer component, and we're going to be able to directly control the position of the stepper motor. As I mentioned, these two examples are inherent into the Arduino IDE. So if you go to File, Examples, Servo, there's the two examples right there. Before we do that, let's see how we need to hook everything up here. So this is a basic schematic, and the great thing about the servo is it only has 3 wires, so it only requires 3 pins to utilize your basic sweep example. So it's going to utilize a 5-volt source, so we'll connect the red wire to the red wire on your servo. And then the black wire, which I have here, is actually going to be your brown wire on your servo itself. So just something slightly different and to be cognizant of. And then we're going to communicate with the data line, which is your orange wire, through the pin number 9 on our Arduino board. So that is a pulse width modulation, or that is a pulse width modulation pin, or a PWM pin. And we really need to have that pin just because that's how a servo motor needs that kind of a signal to function. So you might ask yourself, how does a stepper motor work? So this figure kind of captures it pretty well, and it's all about the width of the pulse itself. A 1 millisecond corresponds to the 0 position. A 1.5 millisecond pulse will correspond to a quarter turn, or 90 degrees, and a 2 millisecond will correspond to a half, or 180 degree rotation. Alright, so before we move on to the actual example, I want to go through some best practices so that you can have success with this sweep example as well as future projects. So let's take a look at some of those. Okay, so best practice number 1, I'm going to talk about zeroing your servo, or finding your initial position that you want. So as you buy a servo, and when it comes in the mail or you pick it up, it's just going to come like this, and it's not going to have any attachments on there. If you were to just attach it and then just run some of your sketches, it may not behave like you anticipated it to. It might not go to the correct angles, or it may not start in the right place. So that can be kind of like confusing, like why did that happen? So what I want to do is zero it, or start out in the correct position. So what I've done is a really basic sketch. I have this example. You can just type it in right here and pause the video, or you could also download it from my GitHub, which I'll post in the YouTube comments below. But basically all that's doing, what you see in the video up here, is it's just I run this sketch, and it moves to a position that I didn't want it to start out in initially. I want it to be, for my purposes, just aligned with the cable itself. So I run this sketch, I start to pull it off, and I struggle a little bit, and then I reattach it how I want that. So that's all this is doing, is like finding where you initially want the servo to start from. So I'm going to move into the next best practice, which is calibrating your servo. Okay, now with best practice number 2, we're going to talk about calibrating. What I mean by that is we're going to use another sketch that I wrote just to find our 0, our 90, and our 180 degree locations. So what I have here is just another basic sketch. Again, you can find this on my GitHub and the YouTube comments below, or you can pause the video and write it out as you see here. So what it's going to do is go from 0, it's going to wait a half a second, it's going to go to 90, it's going to wait another half a second, and then it's going to go to 180, and it's going to wait a half a second and repeat. So in the video, and what I have are two different, and the reason we're doing this is depends on your servos. I have two different ones. I have one from Radio Shack, and then I have one from I think I bought this on DigiKey. Anyways, it's the Tower Pro and the Radio Shack one. So I run this sketch, and in the video you can see here, the Tower Pro runs this correctly. It's going from 0 to 90 to 180 perfectly. Now, in the other video that you see here, I run the same thing on the Radio Shack, and what you'll notice is it's over-rotating on both the 90 and the 180 degree locations. So what I want to do is actually change this. So what I've through testing is I found that actually a 60 and a 150 corresponds, and if I were to run this sketch, correspond to the correct locations of 90 and 180 on the Radio Shack. And again, so that's just another. That's the reason I'm doing this section, is to show you that best practice of calibrating and finding out where those locations are, so that it rotates exactly how you want it to rotate. Cool. So now we're going to move into the sweep example, followed by the knob example. Okay, so now that we've gone through our best practices, we just want to perform that sweep example that we've already set up as well from the schematic. So what we can do is reach our sweep example through File, Examples, Servo, and then Sweep. So this is all ready to go. I'm just going to quickly walk through some of the background on like what this code is saying. So we're going to include our header file of servo.h. So what this is, if you're interested in more, this on the Arduino site, this talks about everything about that header file. So that includes the major functions, which we're using the write and the attach functions. But there's a lot more information if you want to make the most use of this. Again, there's that attach and there's those write functions. So we include the header. We just rename our servo as just my servo. We use a position variable. We initialize that to 0, and then we need to complete some setup steps, which are attaching or activating pin number 9, which we use myservo.attach9, and then we enter our looping section. So we have two different for loops. So this first for loop, it goes from 0 to 180, and then we also need another loop once this is done to go back from 180 to 0. So that once that's done, it'll go back to going from 0 to 180, 180 to 0, and just go on and on endlessly. So if we were to just kind of, again, we want to make sure we have our correct board, our correct processor, our correct port, and our correct programmer. If we upload this, excuse me. If we upload this example, be looking for the done uploading confirmation statement. It's done, and then if you can see in the video right here, it's just slowly going from 0 to 180 and 180 back. Okay, so now let's move on to the knob section. Alright, so now that we're in the knob example, we want to include our potentiometer. So we have to change our setup a little bit. So once we have it plugged into the breadboard, we want the middle pin, the pin of interest, to be connected to analog port 0. The other really important thing to note is make sure you have your power and your grounds in this correct orientation. If you do the reverse, everything will be reversed when you twist it right. The servo will actually move left. So there's some polarization there, so make sure you're cognizant of that. Now in order to reach the knob example, again, it's inherent into that IDE. Let's go to File, Examples, Servo, Knob. I'm going to quickly walk through the code, and then we'll see what it looks like in real life. So again, we want to include our header file. We want to rename our servo just to my servo, and we have two variables. We have our middle pin of our potentiometer as we're calling a pot pin equal to 0, so we're saying we're going to initialize that to 0, and that stands for our analog. That's why we chose analog pin 0 on our Arduino. And then we have this constantly changing analog variable called val. So we need to set up our digital PWM pin as number 9 so we can affect our servo, and then we enter our loop section. So what this is doing is it's changing this val variable every 15 milliseconds. So it's constantly looking for a new value, and so you as you're twisting it, it will have a different result or effect, you could say, on the servo. It's utilizing the analog read function. So that's a common function in the Arduino environment. What that's doing essentially is doing an ADC, an analog to digital conversion on the in this case we're calling it our potentiometer pin. So what it's doing is it's mapping it or converting it from a resistance value to a discrete value, in this case a range of 0 to 1023. The next thing we need to do is, we don't have an angle of 1023, so we need to remap that. So we're using the map function. For the particular variable of interest, we're saying that val map 1023 to 180 and map 0 to 0, and then that corresponds to about, for every 0 to about 5.7 intervals of this will correspond to a 1 degree of shift. So you're saving that. Once that shift has been done, you're saving it under the variable val again, and then you're writing that to the to the servo position. Awesome. So now that we make sure that we have the correct board, processor, port, and programmer, which is everything we want, let's upload this. Look for the done uploading. Alright, it's done uploading. Everything worked correctly, and here's a video of exactly what that looks like. So I'm twisting the potentiometer, and it's resulting in an angle shift on the servo. Alright, that's all I have for this video. Just want to make sure I share some best practices. Make sure you can get up and running, and then where you take it from here is up to you. Let me know if you have any specific examples you want to see done. I'll do my best to make another video based on those comments, and then let me know if I also did anything wrong. I guess that's all I had, everyone. Have a good night, and we'll see you in the next video.